Hey.
Oh, are you ready? Oh,
Mm, 1 more minute.
so welcome
Yes,
to your,
I think I'm ready.
so which algorithm did you choose first? What did you do meanwhile?
To be honest, not really much. I was just thinking about life for these days.
So what did you,
What should I do now?
which day is today or what?
Which day we take a hacker rank or what?
Say it again.
What are we doing now?
So last time it was on Friday, you asked from me what was done for that. So I told you that you should take the algorithms from HackerRank in algorithms. Did you do that?
Mm-mm. No.
No?
Mm-mm.
So how many algorithms in HackerRank inside algorithms have you taken so far?
10.
10. Can you show me your solutions?
I can show you.
You can
I
share your screen and
I use my phone.
why do you use your phone?
No, I will use.
It doesn't matter what you use, you can share it inside your phone or inside computer.
Why I can't go in our call?
Pardon?
Look, I can go into our call.
Is your camera and laptop not working or why do you use your phone?
I can call you again. Okay?
Not call again, but to come to the session from inside your laptop.
I'm here on the session, you see? Here it goes. I
Okay.
click here.
Then you can just close the connection inside your phone and start talking using your laptop.
Okay, I will call you back.
So, alone again. One minute. Invite again. Okay, back and through the laptop camera as asked you. Okay, share now your screen from the HackerRanks website.
How to share with you my screen?
On the left hand
Okay.
side,
Yes, I
there is
see.
a button green with white arrow.
Can you see?
Yes, now go to HackerRank's algorithm site, practice site.
Here?
Practice and algorithms.
Solve challenge.
Yes, let's see what is the task here.
Where's the computer?
It's just for completion. There are two inputs, X and Y, and it should return the sum of the integers. So the first question here is, what are the preconditions?
Preconditions. X is the first integer. X should be integer.
Yes.
Y also should be integer input.
So actually, if we use Java, then we should not check it again, because in Java we have already set the string as the data type, and we even can't feed data from any other types to this function. And we have also set the return data type, which is also in, so the function is not capable of returning any values of any other type than integers. So that's why this case here is pretty easy. Is there a case for injections?
I can hear you, but your quality of microphone is very bad.
Is it too silent or too loud, or what's the problem?
It's like you talk and I hear another, I know, this shh, something like that.
So, okay. Once again, I have no idea where is my microphone that I could connect directly. Well, I found it meanwhile, but where is it? Wow, no idea. I think this just goes lost somewhere. What I can do is I can set my voice louder. How is it now?
Okay.
So, as we don't have any special preconditions, we don't have any exceptions neither here. And, oh, this is the C code. You should choose Java.
It?
Yes, Java 8 is the latest.
Okay, public class solution static int solve me first int a int b. Hint type return a plus b.
So it was easy to do. It was like super easy.
Run code.
Yes, that's really fantastic. That makes sense. So both test cases passed, and now you submit.
Okay. What is the next step?
Here down below you also see that the message. Okay,
Next
there was a
challenge.
message that your submission was queued. So what kind of data structure was used for that?
Array.
Mm,
Hmm?
An array can be used for creating that data structure that is on a higher abstraction level than an array.
Okay, next one. Input
Well,
format. The first line
not the
contains an
same
integer.
question for you. It's connected. So what data structure? If the message is your submission is being queued.
What do you mean by cute?
And then it means that it has to wait until other submissions that came before your submission will be handled.
Okay.
So
Okay.
what data structure can be used for that?
I don't know.
Okay, imagine I submit something, then my neighbor submits something, and then you submit something. And there is only one computer that can process our requests. As my
Stuck.
request is the first one
Stuck.
stack, then
Yes.
it will process your request first, and I have to wait forever.
Okay, then queen, or how to say?
Queen is somebody who is female and who reigns over people.
I'm
It's Q.
Q.
Yes. Which
Q. Okay,
okay.
next task.
Now you can go back and let's see what's the next one.
I already on the next one.
Yeah. What is it? Given an array of n integers, aha, you should find the sum of these integers. So again, what is, are there any preconditions for this function? If you look to the function signature,
Where you can see function signature.
it's in the area where you can write your code.
Here?
Yes, the function signature is the function declaration with the input argument and the return type.
I didn't get what you said.
The function signature is the function declaration. So where is the function declared that should add up these integers?
I don't know.
How many functions do you see there?
Only one function.
What is that one, only one function?
This is.
What is the name of the function?
This public static void.
What is the name of the function?
What do you mean by main?
Name, N-A-M-E.
I understand the words. I don't know what is the answer.
If you want to call that method again, then you should know its name, how to reference it. So what is the name?
I don't know.
Read the function declaration for me.
Function declaration is here.
No, it's all inside the area where you should write your code.
You mean what? Complete this function or what?
Now, complete this function is a command.
In simple areas.
So my first question was, how many methods are there? You told me there is only one method. Then the next question was, what is the name of the method? Because every method has a name. and every name must be also unique.
Solution is the name.
No, solution is the name of what is written before solution.
Public class.
So it's the name of the class.
Simple array sum.
So simple array sum, but previously you showed me another method. Your dad always calls while we have a lesson.
Yes.
So previously you have shown me another method. This time you show me the declaration of simple array sum. So together you have shown me two method declarations already. So let's go back to the first question. How many methods does the class solution have?
Solution have two methods.
Yes, two methods. What are the names of these methods?
Simple array sum and scanner, new scanner.
No. That thing inside, that thing is already inside the method declaration. It's not the name of the method.
The first name is simple array sum. The second name, I don't know. You can tell me.
It's exactly at the same position where you found the name of the first method. Go to the same position inside the second method declaration.
What? Main string?
Yes, the name is main.
Main?
Yes.
Okay.
So you have two methods. One's name is simple array sum and another's name is main. Main is the method that will be called first when you create a new instance of the class. So if you create a new instance of the class solution, then first the method main will be called.
Okay.
And all the instruction inside the declaration, all the method main will be solved one by one. And find the row where the method simple array sum is being called.
Okay. So firstly it goes this and then this.
So tell me the row number where it goes to the method simple array sum.
9.
The 9 is where the method declaration starts. Where is the call to this method? How does Java know that this method must be called?
I don't know.
Go one by one from the beginning, line by line, and find that row.
Static imp simple array sum.
This is declaring the first method, correct? Go on.
Public static void main string args.
Okay, this blah 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 is the declaration of the second method. Now Java knows that the class solution has at least two methods. Go on.
Teacher, I don't understand what you want from me.
I want you to be clear that you know the structure of Java classes and methods.
I know the structure. Here is public class solution. This class is for everything here below. As you said, main method starts first, then we go through this main method. After we finish this main method, we go to this method.
This is incorrect. So as you see, you don't know it. That's why I am asking from you these efficient questions so that you can figure it out. So you started by explaining the class solution by going from top to down. So there you have named two methods. It figured out there is a method simple array sum, and there is another method main. What's the next step?
What should I write here? Complete this function.
You are not so far yet, because Java doesn't know yet that it should go to the line 11. So after you have finished line 24, what's the next line?
24?
Yeah, 23.
I need to call this function.
No. After reading in or parsing, this is called parsing, figuring out which methods the class has. Java goes to the main method and starts executing the instructions line by line inside that method. So after the line 23, it goes to the line 15. Or actually again 14, because there is an input string args, or arg of the type array, which is of type string. And then it goes to the line 15.
Okay, what should I write and where?
So where does it go after completing the line 15 execution? What happens on the line 15?
Scanner in, new scanner.
Yeah, I'm sure that you can read, but what does it mean?
Is it we create new scanner?
Yes. And what is the name of the new scanner?
Simple array sum.
No. Java only knows that there is a function called simple array sum so far, but this method is not being called yet. We are still on the line 15, and my question was, what is the name of the object that you created based on scanner class?
Main.
Main is the method name. We are on the line 15. It's written on the line 15.
System in.
System in is an input argument for scanner constructor.
I don't know, tell me.
So in Java, we read from right to left. On the right-hand side of the equal sign, we find new scanner in parentheses system in. The new, this is where we start reading from left to right again. So sometimes we read from right to left if we have an equal sign, and in other cases we read from left to right. So we start reading by the keyword new. New means that a new instance will be created. So how does Java know what is the base class for that new instance? Where is described what properties and methods should that new instance have? So this is written after the keyword new. And after the keyword new, there is the word scanner. So the scanner is the base class for the new object. And as we put together new and the class name, and then there are parentheses, then it means we call the constructor of the class. And here we call the constructor of the class scanner. And this class constructor takes only one input. We see this input inside parentheses. Inside parentheses is system.in. So system.in is the input value for scanner constructor. So if scanner constructor starts to do something, then it takes this input system in. And we can also explain what is system in. System is another class, like scanner is a class, system is a class. They are both written in upper camel case. We can also distinguish classes from objects this way, but this is not obligatory. This is just a style question. So scanner is a class and system is a class. And in is a property of the class system. This is why there is that dot between them, system.in. So what we access actually is the in property value of the class system. What it means that in, this is the console where we can write anything. So on the right hand side, should be clear everything now, a new instance of scanner class will be created. Then we go to the left hand side of the equal sign. What is written there? Scanner in. This means that there are two things. The first one is the data type, and the second one is the variable name. If you put them together, then we can explain it so that the data type is for the variable. That variable must be of the type that is on the left-hand side. So the variable in is of type scanner.
What is the data structure here?
A data structure is scanner. This is a special data structure that is only available in Java.
Okay.
So it is a class. In a more higher abstraction level, this is a class, and this class has a name, scanner. This has a special structure. So on the left-hand side, we have, so to speak, created memory location. We have allocated space for the variable in, which will be also called as an object. So now we put together the left-hand side and the right-hand side. We take what is on the right-hand side and assign to the memory location we created on the left-hand side. After that, we know that at the location called in is a new instance of scanner. So this is what is going on the line 15.
Why it's so hard? Just one question. Why it's so hard? It shouldn't be so hard.
It looks hard, but actually, if you look at this row,
I know that it's not hard. It's very easy, but you just make it very complicated for me.
Really?
Yes. You explained everything in details, but it makes me like only one line, and it's already so hard. It shouldn't be like this.
It is only one line. This means it's easy.
System in is for console. Scanner in. This is a data type. New scanner. We create a new scanner where we put different variables in console. Yes, no?
Almost, yes. So a new scanner object will be created and put into location called in. So there are two parts. One is the easy part. There is only one line. This is the easy part. And the difficult part is what that one line does. So there are so many things. So instead of this one line, we can also create many lines on the lower level. But in Java, this is the high abstraction level, so we don't need to write those many lines. We can do all those things using only one line.
Okay, what should I write here? I need to complete this function.
We come to this later. Before, you need to understand how Java even knows how to call that function. Let's go to the next line now. Next line is 15. What happens there? Can you explain it now?
Integer n equal in next in. When
So
I have some number, I
explain what is going on there.
integer n is any number equal in next in. This means that I call the next number n plus 1.
No, it is
Not like n plus 1, but it changes. The variables change. In next int until I need to put it in console and write numbers.
Yes, in the console.
Yes.
And what does next int do?
Integer, create array.
No, next int on the line 16.
This int?
Next int.
Next int?
Yes.
That means that I need to put numbers into the next int.
Next int reads the next integer from the console. Yes, after you have written something in the console, then it takes the next value, and if it's integer, then it assigns it to n. If it's not integer, then probably there is an error in the situation. So what we have so far is we have in and we have n. So next
what
line
is this AR?
So on the line 70, again, first we go to the right-hand side. On the right-hand side, we create a new
integer,
or actually type here. New with new we create a new instance, but that int there is not a class. If it would be a class, we would need parentheses. But this is not a class, it's a primitive data structure. It means integer. And inside brackets, we must give there the number of memory locations that we need. So how many integers will be there? And on the left-hand side, we use the same data type for declaring an array. So as we see those brackets there, this means we are dealing with an array.
I know.
So in this case, this array will have at most n elements inside, so n integers.
Okay.
So for instance, if you write into console number 6, then the arr variable will have 6 integers.
Okay.
So line number 18.
For int r, what is r? Array?
Yes, this is an array.
But why should we write this r?
Array.
I don't want this r to be here.
So if you remove it, then you get a compilation error, because after data type there must be a name for the variable.
This is r, this is a name for this int array, and I name it r.
Yes.
Okay. For int r I equals 0, r I bigger than n. Okay, this is understandable.
So can you explain what is going on?
It's not a loop, no?
It is a loop.
Okay, it is a loop. For when we have integer r I don't know, what's that?
This is another variable that will be created before the loop starts. This is the initialization phase. A new variable r underscore I for type int has the value note.
Okay, then we see that this ARI should be bigger than n, and then we increment by 1.
Not bigger, less than n.
Oh yes, less than. Then we increment by
No,
1.
We don't increment yet. After checking whether the condition for the loop is true, the Java interpreter goes into the loop, into the braces part.
Okay.
on the line 19.
This is our array.
No, this is the integer, the index that has the value note currently.
Okay. In next int. Okay, and then we close this loop.
So what does it mean, all those things on the line 19?
It means that if that we need to int next in firstly a, then r, then this thing, and then I. After each element in this array, we need to increment by 1.
So I share my screen as well so that you can understand it better after some of those tools. And then you can see it large. See what is this one. So do you see now my screen?
Yes.
So you should see now something that I have written here. Okay. So for instance, you write into the console number 6. So this is in next int. That 6 will be assigned to the variable n. And now this loop is for going through all the numbers from r underscore I is initially null to 6 minus 1. Because there was the condition that r underscore I must be less than n. So less than n means that the last value can be 5, so 6 minus 1.
Okay.
What we do next, into the array
Equal 5.
to these positions, like r minus, not minus, underscore I, will be written whatever you put next to the system in. So let's say you put the system in or console numbers like 7, 3, 1, 4, 2, and not.
What are these numbers?
These are just random numbers created by me in my head.
What for?
For this example, we must have 6 numbers. So I just have written these numbers are 7, 3, 1, 4,
Yes,
2.
okay, I understand. Firstly, we take 7, then we take 6 minus 1. It will be position 5. No, firstly we take 0.
No, first 7. Because n is not initially.
But we take 0 because 6 minus 1.
So
we start with the bigger number. We start with the index 6.
No. Look, I'm writing this array here now. So this is what was done on the line number, what line we had there where this array was created. Int context and r. So this is r. This is the array. So initially this array is empty. This is what was performed. I open mine. On the line number 16. So on the line number 16, this array was created. This is empty. Now, inside the loop, the first index, r underscore I, is null. So we read in the first number from system in, which is 7, and we put it into array at the position null. Then we go inside the loop to the last part, r underscore I plus plus, which means incrementing the value r underscore I by 1. So previously it was null, now the value is 1. And at the position 1, there's nothing now, the next number is 3. We put 3 to this position. Again, we increment the value for ar underscore I becomes 2. Next number is 1. We put 1 into array at the position 2.
What is this 6 minus 1 for? How do you use it?
Okay, we increment again. The value r underscore I becomes 3. Then we check again on the line number on the line number 17. There is the conditional part. R underscore I is less than n. So this is the place where we check whether the value 3 is less than 6 minus 1, 5. So is it true? 3 is less than 5, or less or equal than 5 in our case. And then we continue. We read in the next value, 4, and as the index is ar underscore I is 3, put that 4 to the position 3.
Okay, then it goes 2 and 0. Okay, I got it.
Yeah, 2 and 0, and then we increment for the last time. The index becomes 6, but 6 is not less or equal than 5, so we stop looping. And after that, we have this array filled in with the numbers from the console.
So we make 6 minus 1, and we see that it's 5.
Yes.
Okay, and we stop here because it's 5 and we have index 5 and we need to stop here.
Yes, exactly.
Okay.
Can you also see the screen that I'm currently showing of the code, or do you see what I have drawing? Okay. What screen do you see?
I see your screen as you draw it.
Okay. Next we go to the line 20. And this is a very interesting line here. So what is going on here? On the line number 20.
20?
Yes.
We close our main. We close our main.
Okay, you have modified it slightly, so you have different line numbers. Please share your screen again.
Mm-hmm. What?
Please share your screen again. Your screen. Okay, and now go back to the code. Yeah. It's line number 21. So what is going on the line 21?
Integer result win result simple array. We write result of this function here.
So what is going on here is different what was going on previously, because here another call stack frame will be created. Again, there are two sides, left-hand side and right-hand side. On the left-hand side, there memory will be located. We know it's of type integer, so the result is the name for that memory location, but we don't know yet what will be put to that memory location result, because we don't have that value yet. The value comes from the right-hand side. And on the right-hand side, what is there?
Integer result.
This is on the left-hand side, but what is on the right-hand side?
Simple array sum.
Yes, this is the place where a call to the method simple array sum will be made. That's the way Java interpreter knows it. The call is called to the place where the method declaration of simple array sum starts.
Okay.
So can you share your screen, please? Again, I see you instead of screen.
Why do you want to see me instead of screen?
Because that way I know on which line we are, because I have different lines.
You want to see my screen or what?
Your screen.
Huh?
Your screen.
Can you see it? Yes.
Yes. So it's a simple array sum. This is a pointer to the function declaration, simple array sum of the same name. So now it goes to the line number 9 and connects two variables. It connects n to n and AR to AR. So whatever you put to n on the line number 21 goes to n on the line 9. And whatever you put to AR on line 21 goes to AR on the line 9. So what we have for n is 6, and AR is the array of these 6 numbers. So these real values go now as input for the method simple array sum. And now is the place where you should start completing the function simple array sum. And now is the question, how do you find a sum of integers inside an array?
I need to do what?
So you have the array, which I have drawn.
Okay.
There are numbers,
Okay.
like 7, 3, 1, 4, 2, and 0. And the result must be 7 plus 3 plus 1 plus 4 plus 2 plus 0. This is what you need to implement now.
So I need to int and write numbers. No?
And no, you should use n and AR.
Which I need to put brackets?
It depends what you want to do.
I need to put numbers 1, 2, 3, 4, 5, for example. Yes?
Yes, maybe I share now my whole screen, so that way you can see. Can you see my whole screen now?
Yes.
Okay. So, yeah. Now I need to rearrange things a bit because it became smaller on your screen, I think.
It's okay.
I switch off this screen. Okay. And apply. So, do you see it well now?
Yes.
Okay. One way to do this is to create an integer like first, which is r at the position 0 plus r at the position 1. But this assumes that we know how many integers are inside the array. We can also figure it out by stating the length, which is r called length. Every array has a property length which tells us how many items are inside the array. So that way we know how many are, but the length is actually the same as n. So we can create another memory location for adding up first and array at the position 2. Then we can go on and create the third variable to add up.
Okay, after that.
Second and position 3 inside the array, then fourth.
I understand what after that.
And so on. But what if we don't know how many items are inside the array? Then we don't know how many different variables we create here. And as you see, these names like first, second, third, and fourth are human created. They are not dynamic. So it's a very static way. What if there are 20 numbers? Then we must create like 20 memory locations here, 20 variables. So it's not a great solution. That's why we need to do it other way. So how can we iterate through an array if we don't know how many items? Well, if we know how many items, we know there are n items. So how do we iterate through an array? We did it one time already on the lines 19 to 21.
Binary search?
No binary search. We don't search anything here. We must go through all the...
In next int. No?
Say it again.
Huh?
Say it again.
In next in.
So on the line 19 to 21, we have walked through the array already, but we filled that array. Now we need to do the opposite. We need to read those values from every location inside the array and add them up.
Okay.
Also, we know that there are two inputs. One is the number of elements inside the array. We can also change it here, so it's not a number of numbers inside array. So this way it's clearer. And the other variable is array of numbers. Are there any preconditions?
No.
I guess there is.
I also guess so.
But these preconditions doesn't disturb us. What if the number of numbers inside array is negative?
It cannot be negative because it's integer.
Integer can be negative.
Yeah?
Yes.
Okay. Then, I don't know. It doesn't matter.
It doesn't matter because if it's negative and our loop condition contains that number of numbers inside array, then it just won't add up anything. Maybe what I came up now is that the number of numbers inside array must equal to the length of array of numbers. Because if it is different, then we might not add up all the numbers inside array. If the number of numbers inside array is less than the length of array, then we only add up part of the numbers. And if it is more than the length of the array, then there will be an exception. So this is something we should check first. Of course, this is not the task here, but from our syllabus perspective, we need to play it through. So if number of numbers inside array is equal to array of numbers length, then we implement addition. Otherwise, is an exception. So as exception, we can do very easily, like print len and number of numbers must equal to the length of array, and that's it. It's the last line of the function. We must not use return here, or still return, just return nothing.
Okay, but what should we write here? Complete this function. You just wrote, it's like you just wrote it as exception.
Yes, I wrote here one precondition and one exception.
Okay.
Now we should implement the non-exceptional part, the normal part.
Okay, yes, let's do that.
So this is the place where the code should iterate to the array, take out all the numbers one by one, and add them together. What do we need for the sum? Where should we put the sum?
The sum?
Yes, because the sum will be changed after every
Sum equal, and we write numbers which we need to add.
For instance, we have here this number slide 7, 3, 5, now 2, 1, just Gaussian numbers, and the indices. Now 1, 2, 3, 4, and 5. Taken that number of numbers inside array is 6. We can have like these things here inside the array. So we need to add up 7 plus 4 plus 5 plus 0 plus 3 plus 1. So how many times did I say plus?
5.
Yes. So I do addition 5 times. But 5 times, it's actually the same operation. It always takes 2 operands. So, as we have similar operations, we must use either loop or recursion. As we know how many times we need to do that thing, the operation, we can use a loop. If we wouldn't know, then a recursion would be a better approach. But of course, it's also a style question. You should be able to use both ways. So let's first implement it as a loop. So before we can start looping, we need some initial conditions. We can write everything here inside the for. For has 3 parts. This is the part, the first part is for initialization. The second part is the condition. And the last part is change. So first we set the initialization. We need a variable for holding the sum, because After every time we iterate through here, we say 5 times. So after the first time, we have a sum. After the second time, that sum will be changed. After some third addition, the sum will be changed again. The same sum will be changed. So here, initially sum is not. Nothing has been added yet. But we need something else more. We need a variable that pulls the index inside the array.
Until
you could
5.
also pull it, the index is not. So this is all that we need before we can go into the condition part of the loop. We need to have a memory location that stores the sum after every iteration, and we need the index because we change the index after every iteration. So what is the condition now?
For int sum equals 0, int index equals 0. The condition is while index equal 5, we add numbers.
So if you put it here 5, then what happens is that it never goes into the loop. Oh, maybe it goes. Okay, let's let it, as you said, 5. What should we write into the change part?
We need to write I++.
We don't have I.
What do we have?
We have index.
Index plus 1.
Index
Plus.
plus. Okay. Index plus plus. So what do we do here inside?
We write sum array sum equal in next int.
You said something like this.
Yes.
And then?
And then sum.
I have written some.
Like array.
Ah, you mean this one?
Yes.
Bracket. Mm-hmm.
Array. Oh, is sum.
Again some.
Yes. No. Equal.
Are equal here or there?
Not here. Here.
Okay.
Next int. Next int.
What is next int?
In dot next int function.
Yeah, it would be optimal to read those numbers directly from the console, but this work has been done for us already. It has been done here in the main function. So we have those numbers inside the array of numbers already.
Okay, now how should we add them?
So we should access all those numbers inside the array one by one. So the array pointer is array of numbers. We know that it is an array, so now we access every single location. The location identifier is index, because we change index each time. Initially it is not, and after each step we do plus plus to the value of index. It will be 1, 2, 3, 4 until it is 5.
Okay.
So if there will be 6, then we end.
Okay.
But now there is a mistake here. And the mistake is this part here.
What should I write here?
We cannot write it this way because sum is not an array.
Okay.
Sum is just an integer.
Okay.
So what should I change here?
You need to write, I don't know, simple array sum. No, I don't know.
So it is just sum.
Just
Now,
sum. Okay.
okay, now I show you what's going on here. It doesn't have a decoder, a quick task, but we do it here. So initially, sum is not, index is not, and out is less than. Oh, now we have a problem here because your condition is that index must be 5, but initially index is not. So it never goes inside here. It goes directly to the line 18 and finishes this function. So the condition must be changed.
Okay.
This condition must be true for going into line 17. So how would you change it?
I don't know.
Think of that. So what must be true to access an element inside the array?
I
What are the possible
6 minus
index?
1 shouldn't be 5.
What are the possible index values inside the array?
Possible index inside an array 5, 1, 0, 2, 3, 4.
Yes, these are those possible index values. So it can be not 1, 2, 3, 4, 5 until we reach number of numbers inside the array. So this must be the condition. And this is the index here.
Okay.
So if we say that the index is 5, then it only goes into this block when index is 5. But index is not initially.
It's time already.
You want to end?
I know, but it's 1 hour already.
I can go on. It's the question what you want to do.
So, is it long to finish this algorithm?
So what I want to do today is that I want to make clear for you that you really understand how to create this loop here. And after you have a correct loop, you have the answer already.
How long it takes to finish this algorithm?
It's unpredictable. It depends on you. And it also depends on me. We must reach the same wave.
I just want to follow this plan that we have 1 hour lesson.
It's difficult to follow that 1 hour rule because, as you see, if 1 hour is filled up, then and we stop, then we can't finish. And on the other hand side, we have finished something, but we have some time left. So what we do? The best thing would be that we finish when we are done, not depending on the duration.
Of course, for you it's not depending, but for me it's dependent. But okay, let's finish this algorithm. I think it's 6 more minutes.
Can be, yes. So the thing here is you should change this part that I have highlighted.
Okay. Index equal n.
N is better already, but instead of n, what we have
0.
We have number of numbers inside array.
Okay.
But still, it didn't change anything. We need to change this operator here.
Equal. Oh, smaller.
Yes. So now we have note is less than 6, which equals to true. That means we go in, and for the first time, array of numbers at the position index, what number we find there.
7.
Yes, 7. So sum, this is also, we need to change sum plus equals. So the new value for sum will be 7. Then we change index
to 1.
by incrementing it by 1 to 1. Yes. Then we check this condition. Is 1 less than 6 equals to 2? So we go here again. And what number is at the position index now?
4.
Yes. We add up 4 to the previous value of sum, we get 11. Again, we increment index. Index becomes 2. We check for the condition here. 2 is less than 6. It equals to true. Now, what number we find at the position index?
3. Oh, 2. 2. 5.
Not 3.
Index 2, number 5.
Yes, we add up 5, we have 16. And we go on, increment index to 3. 3 is less than 6. It equals to true. And the same way, we add up note, which means that the new sum is 16 still.
Again increase. Have 4.
Yes. Now it goes to 4.
4.
4 is less than 6. Here we find 3. We add 3 to 16, we get 19.
Number of numbers.
Again, incrementation, 5. 5 is less than 6.
1.
And at the position 5, we find 20. And increment index again. Index becomes 6. Now, 6 is not less than 6. It equals, evaluates to false. That way we end this for cycle, and there is one more thing to do in this function. If we look into this main part here, a new call stack frame have been created here. The value that this function returns will be assigned to result. So in order to return something from this function, it must return the value. So what I write here in the line 19.
Return.
Return and what?
Array of numbers.
Array of numbers?
Oh no, return sum.
Yes, return sum. And after that, result as sum. And then we go to the line 36. Here we call the class system, which has a property out. System out means console again, but for writing this time. And this is also an object which has a method println, which writes a line, something that we put here as input and the line delimiter. And this something is the result value or sum, because this sum from the line 19 will be stored in the result of the line 35. And if we run here, now it doesn't work because we have some problems there. Identifier expected. So we have a problem here. We could solve it the other way. So int sum is not, and Maybe in Java we can't do it this way. We can do it so. And yeah, run. And something else. Ah, semicolon is missing somewhere. Line 16, the same line. These small things, but big deal for Java. And again, error cannot find symbol number of numbers inside array 17. Number of numbers inside array. Ah, n is missing. Number of numbers. And 24 incompatible types. We can state here something like -1 because the return type is not void, it's int, so it always must return an integer. But actually a sum can be negative. So now this place here, instead of system out println and return -1, could do something else, like throwing new exception, and we put the message there and don't return anything here, and we take this return from here and put it to the end of the function. And maybe it also must be throwable. Let's see, the compiler says it right away if we need it. Cannot find symbol sum. Aha. Now is the question, why a Java compiler cannot find this sum? Can you see the problem?
Because we, I don't know, we have plus, some plus.
So we should look where a sum is created initially. So sum is created initially here, inside a block that starts here and ends here. We cannot see or access the variable outside of the block where it's created. We can access it inside the block somewhere, but not outside the block.
Okay.
So this means we need to create this sum before the block starts, like here on the line 11. Oh, what does the compiler say now? Now sum should be visible and accessible. Okay, unsupported exception. That means we need to create here throws exception and run it now. Still unreported exception must be caught or declared to be thrown. Or maybe the class throws exception.
Okay.
7. It's not possible to write it here. Maybe here. Throws exception. And now it passes the test case.
Okay.
So what we did here, we used 2 loops. This was implemented previously. Another one was here. We identified precondition which had 1 exception, and as the case in case of exception, we created a new exceptional case through throw new exception, or what happened now. For that, we needed to also write throws exception for both methods that were connected to this exception.
Okay. I will do my version. I understood how to do that. I will do it on my computer. And
yes, do that.
Okay. Thank you, Zen.
Okay, let's finish now.
Have a good evening.
Yeah, you too.
Bye bye.
Bye.